Imagine looking up at the night sky, filled with countless stars, each a potential sun to planets of its own. The universe is vast, containing billions of galaxies, each with billions of stars. It's mind-boggling to think that among these countless stars and galaxies, we might not be alone. But what if I told you that intelligent life might be much rarer than we think? According to recent studies, just 4 in 10,000 galaxies may host intelligent aliens. In this video, we'll explore why that might be the case. If you're enjoying the video, don't forget to hit the like button and subscribe for more content like this. What it means for our search for extraterrestrial life. The idea of intelligent life elsewhere in the universe has fascinated humanity for centuries. From ancient civilizations who believed in gods residing in the stars to modern scientists searching for signals from distant planets, the question of whether we are alone has driven much of our curiosity about the cosmos. But despite our efforts, we've found no definitive evidence of intelligent aliens. The concept that only 4 in 10,000 galaxies might host intelligent life offers a possible explanation for this silence. It suggests that intelligent life is not just rare, but extremely rare, perhaps even to the point where we might be one of the only intelligent civilizations in our entire galaxy. To understand why intelligent life might be so rare, we need to look at what it takes for such life to develop in the first place. Life on Earth has taken billions of years to evolve from simple single-celled organisms to complex, intelligent beings like humans. This process of evolution is driven by a delicate balance of environmental factors and random mutations. If any of these factors had been slightly different, intelligent life might never have evolved on Earth. One of the key factors in the development of intelligent life is the presence of stable, habitable environments. For life to evolve, a planet needs to be in the habitable zone of its star, where temperatures are just right for liquid water to exist. But even within the habitable zone, there are many other conditions that must be met. For example, the planet needs to have a stable climate, protection from harmful radiation, and a sufficient supply of elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, which are the building blocks of life. But even if all these conditions are met, the evolution of intelligent life is not guaranteed. Life on Earth has gone through many mass extinctions, where most species were wiped out. Each time, life had to start over, and it was only through a series of fortunate events that intelligent beings like us eventually evolved. This suggests that the evolution of intelligent life is a rare and fragile process, one that might only happen under very specific conditions. One concept that helps explain the rarity of intelligent life is known as the Great Filter. The Great Filter is a hypothetical barrier that prevents life from evolving to the point where it can communicate across interstellar distances. This filter could occur at any stage of a civilization's development. For example, it could be that the emergence of life itself is incredibly rare, or that complex life forms rarely evolve. Alternatively, it could be that most civilizations self-destruct before they can develop the technology to communicate with other worlds. If the Great Filter is in our past, it means that life on Earth has already overcome the most difficult obstacles to becoming an advanced civilization. But if the Great Filter is still ahead of us, it could mean that our future is uncertain and that most civilizations never make it past a certain point. The idea that just 4 in 10,000 galaxies might host intelligent life suggests that the Great Filter could be very effective at preventing the emergence of civilizations like ours. The rarity of intelligent life also ties into what is known as the Fermi paradox. The Fermi paradox is the apparent contradiction between the high probability of extraterrestrial civilizations existing and the lack of evidence for or contact with such civilizations. In other words, if intelligent life is common in the universe, why haven't we found any signs of it? One possible answer to the Fermi paradox is that intelligent life is indeed very rare. If only 4 in 10,000 galaxies host intelligent civilizations, the chances of us being close enough to detect one are incredibly slim. Even if a civilization exists in a neighboring galaxy, the vast distances involved mean that any signals they send might take millions of years to reach us. By the time we receive a signal, the civilization that sent it could be long gone. Another possible explanation for the Fermi paradox is that intelligent civilizations are intentionally avoiding contact. This could be due to a variety of reasons, such as fear of more advanced civilizations, the desire to observe without interfering, or simply the fact that they have no interest in communicating with us. Another factor that might explain the rarity of intelligent life
is the concept of galactic habitable zones. Just as there are habitable zones around stars where conditions are right for life to develop, there may also be habitable zones within galaxies. These zones are regions where the conditions are favorable for the development of complex life. In our galaxy, the Milky Way, the habitable zone is thought to be a region that is not too close to the galactic center, where the radiation levels are high, and not too far out, where the supply of heavy elements needed for life is low. Planets within this zone are more likely to have the right conditions for life to evolve. However, the habitable zone is just a small fraction of the galaxy, and even within this zone, the chances of intelligent life evolving are still low. If we extend this idea to other galaxies, it means that only a small percentage of galaxies might have regions where intelligent life can develop. And within those regions, the chances of intelligent life evolving are still slim. This could explain why just 4 in 10,000 galaxies might host intelligent aliens. One of the key factors that might influence the development of intelligent life is the presence of plate tectonics. Plate tectonics is the movement of large sections of a planet's crust, which can lead to the formation of mountains, earthquakes, and volcanoes. On Earth, plate tectonics plays a crucial role in maintaining a stable climate, recycling nutrients, and creating diverse habitats for life to evolve. However, not all planets have plate tectonics. In fact, Earth is the only known planet in our solar system with active plate tectonics. If plate tectonics is essential for the development of intelligent life, this could further limit the number of planets where such life can evolve. Planets without plate tectonics might have stagnant environments, where life is unable to evolve beyond simple forms. This could be another reason why intelligent life is so rare in the universe. In addition to plate tectonics, a stable environment is also crucial for the development of intelligent life. Life on Earth has thrived because our planet has had long periods of stability where conditions have remained relatively constant for millions of years. This stability has allowed life to evolve and diversify, eventually leading to the development of intelligent beings like humans. However, not all planets have such stable environments. Many planets experience extreme fluctuations in temperature, radiation, and other conditions, which can make it difficult for life to survive, let alone evolve into complex forms. Even small changes in a planet's environment can have a big impact on the evolution of life. For example, a sudden increase in volcanic activity or a large asteroid impact could wipe out entire species and set back the development of life by millions of years. This need for stability further limits the number of planets where intelligent life can evolve. Even if a planet is in the habitable zone of its star and has the right conditions for life, it still needs to have a stable environment over long periods of time. If such stability is rare, then intelligent life will also be rare. Despite the challenges, the search for extraterrestrial life continues. Scientists are exploring a variety of methods to detect signs of life beyond Earth. One approach is to search for biosignatures, which are chemical indicators of life in the atmospheres of exoplanets. Another approach is to listen for signals from intelligent civilizations, a field of study known as SETI, Search for Extraterrestrial Intelligence. However, the idea that only 4 in 10,000 galaxies might host intelligent life suggests that our search might be more difficult than we thought. If intelligent life is that rare, we might need to look at thousands or even millions of galaxies before we find any evidence of it. This means that the search for extraterrestrial life could take much longer than we expected, and we might need to be more patient in our efforts. Another challenge is the possibility that intelligent civilizations are using communication methods that we don't understand or can't detect. For example, they might be using advanced technologies that are beyond our current capabilities, or they might be communicating in ways that we haven't yet discovered. This could mean that even if intelligent aliens are out there, we might not be able to find them with our current technology. The idea that intelligent life is so rare has profound implications for humanity. If we are one of the few intelligent civilizations in the universe, it means that we have a unique responsibility to protect and preserve life on Earth. As the stewards of what might be one of the few intelligent civilizations in the cosmos, we have a duty to ensure the survival and flourishing of life, not just on our planet, but potentially beyond it. This realization can also serve as a wake-up call. If intelligent life is so rare, then the loss of our civilization would be an irreplaceable tragedy on a cosmic scale. It underscores the importance of addressing the challenges we face, such as climate change, nuclear proliferation, and other existential risks that threaten our future. On a more hopeful note, understanding our potential uniqueness can inspire us to push the boundaries of exploration and innovation. The vastness of the universe is a reminder of how much we have yet to discover, whether it's sending probes to distant planets, developing technologies to detect faint signals from other galaxies, or eventually venturing beyond our solar system. The pursuit of knowledge and the search for life beyond Earth are endeavors that unite us in a common goal. The idea that just 4 in 10,000 galaxies may host intelligent aliens is both humbling and awe-inspiring. It challenges us to rethink our place in the universe and to appreciate the extraordinary circumstances that have allowed us to exist. While the Great Silence may suggest that intelligent life is incredibly rare, it also highlights the preciousness of what we have here on Earth. As we continue to explore the cosmos and seek out answers to the great questions of existence, we must remember that we are not just searching for other civilizations, we are also seeking to understand the value and significance of our own. Thank you for watching. If you found this video thought-provoking, please give it a thumbs up, subscribe to the channel, and let us know your thoughts in the comments below. What do you think about the rarity of intelligent life in the universe? Do you believe we're truly alone, or are there other civilizations out there waiting to be discovered? Let's keep the conversation going, and as always, stay curious and keep exploring.